Yes, so thank you very much again. Thanks for the presentation. Thank you for inviting me here. It has been said, I work a lot with trace metals in agriculture as well as in mining areas. So whenever you're dealing with trace metals in mining areas and trying to do research with synchrotron, it's easy because we have a lot. When you switch from mining areas to agricultural, tiny little quantities of selenium, etc., in plants, this starts to be complicated. So this is not my role. This is the role of the guys who work with synchrotron. I'm just a user. So I'm going to try to show you some information concerning the use of synchrotron, at least what I expect from it, and the discussions that I have had. And I believe I was invited because probably I was the first one to use synchrotron facilities in agriculture and in soils in Brazil more than 10 years ago. So I'm still curious, and I know there has been a lot of advancements, and I'm wondering what we can do more in terms of using synchrotron for that. So, okay. So this is the outline of my presentation. I'll give a little bit of rationale on this new concept of soil security. I don't know if you have ever heard. I'm pretty sure that you know soil security. And in fact, I mean, between you and food that is safe, has quality, is secure, and I'm pretty sure that you will accept this food. So I already talked about 4 dimensions of food security. But I will try to connect this with soil security and then what we can do by using synchrotron facilities. So the first issue is trying to tie soil security with food security. This new concept of food security is not, soil security is not that old. It has only 10 years. And it includes 5 dimensions, which I'm going to talk about a little bit more later on. But it comprises 3 old concepts of soil quality, soil health, and soil protection. So with this, we are trying to set a connection between what we have to have in terms of food security and soil security. So this is a publication that was done about 10 years ago, and it ties the concept of soil security with all those global challenges that we have concerning water, climate, energy, ecosystem functions, and biodiversity, as well as food security. We have this connection between all those challenges, and food security is part of that. As I said, we search for quality, we search for enough food, we search for safety, but in order to do that, we have to have all those functions in terms of soil. Sorry, just missed that. The previous functions were defined as 7 functions, and mostly after the declaration of the International Year of Soils, we have switched to those 11 functions. I'm going to talk mostly about the connection between food and soil security, but we are pretty sure that we have to have all those functions together in order to be able to be here. We have seen a lot of this before in the talk that Rebecca showed us, so I'm going to focus on that. So we have seen aspects of soil degradation, and for sure agriculture is the biggest, the major driver of degradation, because agriculture is done in soils. And when we talk about that, we talk at least about concerning extension. Sometimes intensity is not that much, but for sure agriculture is a major driver of degradation. And in order to be able to produce food that is safe, food that has quality, that could be produced for a long period, and that people accept, we have to have safe soils of good quality. So that's why we try to do this connection. And I like very much this next cartoon that links what we have in the soil with what we should have in our food. Most of the nutrients that we understand that are essential for plants are essential for humans. Some of them that we do not consider essential for plants, like selenium, like iodine, they are not here. But we also have to study these elements in order to be able to provide to people what they need in order to survive and to be able to live with a life that is healthy life. And a lot of concern has been talked about micronutrients. And as I said, when you use synchrotron facilities to do work with micronutrients like selenium, I've never done with iodine, and I did not see any work with iodine, but I know that selenium is kind of complicated. So this is one thing that you want to see. We have seen information on zinc. I'm going to try to show you some of this work that's being done by our group and by somebody else. So connecting soil and food security with a sustainable world and with all those SDGs is pretty much obvious. And that's the reason why I'm here. I'm trying to show you what we could do in terms of soil and food security studies and by using synchrotron light source, at least what I expect we can do. So what are the topics that we could address when you use synchrotron facilities on studying soil and food security? First of all, I would like to go back to those dimensions, the 5 dimensions of soil security. So the first one is capability. Are soils capable of producing food? In this case, the function is to produce food. If they are not, can we change this condition? I like to use the examples of the cerrado soils in Brazil. I don't know if you know the Brazilian savanna. 50 years ago, nobody would believe the Brazilian savanna would be producing 70% of what we produce right now. So it's because of changing the condition, and by changing the condition, we could use information from synchrotron facilities to see, for example, phosphorus behavior. When we put lime, what happens with zinc, what happens with manganese, and this is really interesting for us. Capital, what is the value that people give to soil? Connectivity is another information important in terms of this concept of soil security. And last but not least is condition. What is the information that we can get from synchrotron facilities in order to help, for example, regulations when it comes to soils and food, for food as for sure, but not for soils. And the 5 dimensions, as I mentioned before, we have to be able to use those information, those studies also, in order to be able to show that we can produce food that is enough for people. We have heard about hidden hunger. Hidden hunger is a big problem, probably the biggest problem right now in Latin America, but chronic hunger is still the biggest problem in Africa, in Southeast Asia, so people do not have even the small amount of energy that they need. But besides that, we have to have food that has quality. So we talk a lot about micronutrient deficiency, so what we can do in order to be able to have food of good quality. Food that is accepted by people. We have heard information on GMOs. I would love to see the GMOs in the Francophone part of Africa. The Anglophone part is a lot easier than the Francophone, but doing work with GMOs that could have higher contents of iron and zinc, etc., is also possible to see this using synchrotron facility. Talking about safety, we avoid contamination, have seen many aspects here, and last but not least, the ability to be able to continue producing, so the resilience of all the systems. So what are the topics that we could address? I've tried to point some of the topics, but in the end, I believe we could address all the major dimensions by using the studies with synchrotron facilities. So talking about food quantity, whichever technology we could do in order to be able to produce much more than we are producing right now, increase yields, as we have seen here, is going to be good. Food quality, enhancing the nutrient density, we have seen a lot on zinc, and I'm going to show you some work on selenium. This is really important. Safety, avoiding contamination, acceptability. I'm going to show some information on very nice work done using imaging with synchrotron facilities, and resilience. And for soil security, I would try to connect some of the work that I'm going to show later with capacity, condition, and codification, so those 3 dimensions. So to start with general information, I just gathered this information from Scopus database last week. I tried to put those words together: synchrotron, soil, food, and security. When I put all the words together, I got only 3 papers published so far with information concerning everything together. And you have seen that we have a lot of information on food and security, soil and security, but not on soil, synchrotron, food, synchrotron. So we still have a long way to go. And when I try to put this a little bit more detail by using composite words like soil quality, soil safety, etc., we end up with almost nothing, less than 10 papers. And most of the 10 papers were published in the last 10 years. So this is good for all of those who work with synchrotron facilities, because we have a lot of work to do and we are able to get enough money. So we should present these in order to get money from the grants we are going to ask for. As you have seen here, soil quality, food quality, and synchrotron, I could not find anything. It's true that people sometimes do not put the words in their abstract, but it is title, abstracts, and keywords. So to start with some of the work that we have done, I'm going to show you only 2 examples, and the work that has been done worldwide. I just like this very much, this image that was taken from one of the proposals. Unfortunately, the 2 students got their job. They are teaching a lot. They did not have time to publish, but we are pushing them in order to publish this. This is an image of selenium being transferred into a tripartite symbiosis of fungi, mycorrhizal fungi, nodule, and the root. So selenium transfer into the root, and we have images also from other nutrients. Well, talking about the work that we have done, as I said, this is the first work that we did on areas, mining areas. This was not in Brazil. This is part of a work done with one of my students who is now teaching in Alagoas. They had this big problem in Isla de la Juventud in Cuba of areas contaminated with arsenic, lead, and cadmium. And we were studying arsenic, and we were trying to see if arsenic would be available or not to be transferred to plants or to the water. So this was one of the first work that we did. We were able to show using XRD in the facilities as well as XFs the state that arsenic was in the soil. And in the end, we saw that the bioaccessibility of all the arsenic that was in the soil, and in some waters, we found up to 6 ppm, which is 6,000 ppb of arsenic. This is 600 times bigger than the quality level for drinking water. But we were able to show that arsenic was mostly related to iron. And this decreases a lot, the bioaccessibility, but we still have a lot of arsenic in this environment because we're talking about thousands of ppms of arsenic in the residues. Then we have done also some work with selenium. This was work done by students of Professor Guilherme Lopes that was done in our facilities in Brazil. This is interesting to show that we have most of selenium in the inner part of the grain. Selenium, contrary to zinc, tends to accumulate in the outer part because of phytate. In the case of selenium, it goes inside. And for countries who eat polished rice like we do, it's good to have selenium inside. And one curiosity, we have to put a lot of selenium in these plants in order to be able to detect selenium in the grain, inside the grain. Well, now it's a very nice work. It's a reference work. One of the authors is here. That was done in order to do images of different elements in soils and in plants, etc. So here we have selected elements that were chosen to be described in this very nice review, elements that we need for people to have quality elements that are important in terms of contamination. And with this work, I believe we certainly could address aspects of food safety, food quality, And soil capacity, soils are able to produce, for example, if I do not have selenium in the soil, I would have to provide selenium extra through soil or foliar application, in our case, mostly foliar application, and also condition. So only to have an example of the dimensions of soil and food security that we could address by reading this very nice paper of one of the authors who is here. So this is also a paper that we have done. Amaral was one of my former students. He's now at UC Davis, but he was doing part of his work with Angelia at UC Delaware. We were able to use XRD and also some other information from synchrotron, X-ray absorption spectroscopy, to show the relation between the amount of iron and arsenic in the root system of rice. In this case, this information was important to show that even though iron could be linked to arsenic, which tends to decrease the availability in many cases, arsenic could enter the grain, but by providing silicon, we would be able to decrease the amount of arsenic inside the grain. So by doing this, I'm pretty sure that we have addressed really well food safety and acceptability. If you tell people, okay, you could eat this rice because there is not going to have arsenic on it, so acceptability for sure. A third one, which now uses tomography, it was linked to the quality of flowers, and flowers that could, by doing this work, they were trying to show that we could enhance bread quality. And also by using small angle X-ray scattering, they were trying to understand the structure of proteins. And by doing this, they were able to show that when they tie the two information together from those two methodologies, they could describe a lot of information, interesting information from flowers that people would need in order to have quality and, again, acceptability. So people like bread. They want to see if the bread has a good quality in terms of protein content, etc. And also if it's a nice bread to eat. So acceptability is, again, part of that. Another interesting work was done in Bolivia. In this case, they had high levels of arsenic. I don't know if you know the work that's been done with arsenic in Latin America, and we have many, many natural high contents in many places in Latin America. And so this guy was trying to understand behavior of arsenic in root systems. So he split soils in between rhizosphere soils and bulk soil. And they were able, by using synchrotron-based techniques, to show that the amount of arsenic in the rhizosphere was a lot bigger. And arsenic was mostly tied to iron. And in this case, arsenic stayed mostly as arsenic 5, which whenever it's tied to iron, it decreases a lot the bioaccessibility. And he was able to show, even by doing, trying to change the oxidation state by doing water saturation or by using dithionite, that arsenic would still stay as arsenic 5, which is really good to show that this is a picture of the work, that we would be able to have food safety in this case. So even by changing, for example, if you put a lot of water and you do rice cultivation in waterlogged soils, even in this situation, the rhizosphere would be able to oxidize the rooting system, and still a lot of arsenic stays outside, not inside the grain. Another work that's very new is from 2022. It uses synchrotron imaging to see features. We have seen very interesting information here on seed, aflatoxin. So we could use this kind of information to see structures and functions, to understand use, conservation, and productivity. And another very nice information on synchrotron absorption tomography with microcomputed information, and also synchrotron phase contrast imaging. They were able to understand the structures of raw and processed food products in order to promote safety and security. And again, this could be related to food safety, quality, and acceptability, three of the dimensions previously mentioned. And in this case here, this is a work that's been done, also a very new work. I'm trying to show changes on silver nanoparticles that were used as pesticides, in this case in soybeans, and they treated the plant, and they were trying to see if part of this silver nanoparticle would stay as silver nanoparticles or they would change because toxicity changes. And they were able to show that by having soybean materials that produce a little bit more of glutathione, they would be able to change this kind of silver, and toxicity would decrease. This is part of the pictures that they show. So here, by doing linear combination fitting, they show the structures in the soil, mostly as silver nanoparticles. But when we move to roots, part of that is changed to glutathione. This information is especially interesting for me because we do a lot of work with selenium, and you have seen that whenever we put selenium in plants, especially in soybeans, you are going to be able to increase the amount of glutathione. So by adding selenium, for example, in a situation like that, where we have silver nanoparticles, we could decrease a lot of the toxicity of silver. So this is really interesting. So in this case, we are talking about all the dimensions of food quality, food security. This nice work here, it's really connected to a lot of information that was presented today. The idea is to transfer zinc from the outer part of the grain to the inner part of the grain. And by doing some specific work with selected germoplasm, this guy was able to show that the ratio of zinc in the endosperm to the ratio of the zinc in the aileron changed from 0.1 to 5.5. So he was able, by doing synchrotron work, to show this change. And with that, we now say that we have seen also a lot of this information here that we could try to switch by using better genotypes in order to have a lot more zinc inside the grain than outside. This is especially important in countries like Brazil, and I believe this is also the fact in many countries. I've been in Africa, in lots of countries where they eat polished rice. So if you move zinc inside, this is going to be a lot better. So this is the kind of work that they did, showing how zinc would be inside and not outside. So food quality is for sure one aspect that was addressed here, and acceptability. If you tell people, if you eat this kind of rice, you're going to get much more zinc. You're going to be bigger. You're going to have a better brain, etc. Your hair is not going to fall down because zinc deficiency has a problem with that. So they would accept this a lot better. And this very last one, I like very much this work again. Enzo Lombi was part of this team because it addresses it shows how we can use synchrotron information. So in this case here, they were trying to see how zinc and manganese, I select information from manganese, would change from the point you have applied the manganese source towards for example, the zone where the root is, because this is really important on trying to have manganese in a situation, and zinc as well, but in this case manganese, that plant could be able to absorb. So this is some information on manganese oxidation change from near the granular, far from the granular. And for me, this is a nice way of proving that we could use this very high quality information from synchrotron facilities in order to address all these aspects. So as final remark, I would like to leave you with this take-home message. Food security for sure is a major challenge that we need to address by addressing also soil security. We know food security for a long time, at least for 20 years, but this concept of soil security is pretty new. And we have all these dimensions that we have tried to show you, and I'm pretty sure that with the use of synchrotron facilities that we have seen here, we are going to be able to address all these dimensions, and then we'll be able to have better soil and better food security. The last message is a propaganda from one of our institutes. Yeah, I still have a little bit of time. We just got grant for a brand new institute on soil and food security in Brazil. The grant was approved. The grant is still not there, but it's a little bit more than $1 million. And we are glad to have partners from our state, Our Synchrotron facility in Brazil is a good partner of us. We have many partners in the state of Minas Gerais and all around Brazil, but also we have partners all around the world. And we are glad to have additional collaborations in order to be able to continue producing food of good quality in a very nice soils. I have to rephrase one aspect of the very beginning of our talks. Brazil, agriculture in Brazil is really important when it comes to everything that's related to agriculture. 25 to 30% of the GDP is agriculture, and 25 of maybe 30% of employments comes from agriculture. So we have to be sure that we have safe, good quality food and very nice soils, otherwise we're going to go down. Thank you very much for your invitation.